Good morning, students. Mr. Winter here. I want to take a look at the homework that you were assigned this week and walk you through anything that may have been difficult for you. So go ahead and find the homework that you worked on this week from 1.2.1 and let's get started. So again, here you are in the textbook. How can I describe a graph? We're going to scroll right down to 1.33, and this problem says copy these diamond patterns and use the pattern you discovered earlier shown at the right to complete each of them. Some of these may be challenging, so I'm going to take a picture of that. And what we learned here on the right, if I can get this to work, of course my pad's not plugged in. Alright, so over here at the right, what this is saying is if I have a number x and a number y, up here it's going to be when I multiply x times y, and over here is when I add the numbers x plus y. So if we look here, I have the number 98. That comes from when I multiply these two numbers together. Well, I only have one number. So what I have to do is say, well, if this is negative 98 and I got it by multiplying 7 times some number to get negative 98, well then I simply need to divide by 7. If I divide by 7, I get y equals negative 14. And so I put that in the box, negative 14. Well then here, this one comes from if I add x plus y. So 7 plus a negative 14 is equal to negative 7. Remember, you can use your timeline if you're struggling to remember how to do that. What do you mean by timeline, Mr. Winter? Well, I actually mean the number line. But I start at negative 7 or positive 7. If I go this way, minus 14, I would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then I could find out what is this number. It's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. That's how I use a number line to subtract. Alright, here we go. So now I know x and y in b, so this is just x times y. So 3 over 2 times 3 over 2. We multiply numerators and get 9. We multiply denominators and get 4. So this value up here should be 9/4. Down here, if I add 3/2 plus 3/2, it's like saying I have 3 half slices of a pizza plus 3 half slices, and I end up with 6/2. Well, we can reduce 6/2 to just the number 3, because 6 divided by 2 is 3. And there we go. Here I have 5/4. Go back. I have 5/4 is the product of this value times negative 5/2. So x times negative 5/2 equals 5/4. Well, if I multiply by negative 5/2, there's two things you can think of. I can divide by negative 5/2, and you maybe learned that when you divide by a fraction, you can multiply by its reciprocal. So if I divide both sides by 5/2, 5/4 multiplied by negative 2/5 is the way of dividing by a fraction, and we'll walk through that specifically why at another date. But 5 times negative 2 is negative 10. 4 times 5 is 20. This fraction reduces to negative 1/2. And so my answer for this value is negative 1/2. And that makes sense that it's negative, because a negative times a negative is a positive. Alright, now I need to find this value in here, and we get that and it says x plus y. So negative 1/2 plus negative 5/2. They have the same denominator, so I can add the numerators. Negative 1 plus negative 5 is negative 6. Negative 6 divided by 2, this reduces or simplifies to negative 3. Alright, now I need a little more space, so I'm going to clear this off. You have the power of pausing and going back and watching this over and over again, and then coming with some questions if you still have them. You can join me Friday. If you're watching that, it's today. Join me Friday at 10 a.m. for my office hours, and then we can talk through any of these problems. Alright, here I get negative 10 and something equals 0. So remember, x plus y equals 0. I know negative 10 is my x value. So what plus negative 10 is 0? Well, you're saying, well, the opposite of negative 10 would be positive 10. So I'm with you. I would say y equals 10. Now to get this top one, it's negative 10 times 10. Negative 10 times 10 equals negative 100. Alright. Let's take a look at these absolute value expressions. If you remember, an absolute value asks us how far is this number away from 0. So how far is negative 100 away from 0? Well, it's 100 away from 0. And so we have 100 minus 98 gives us a value of 2. B over here says 5 times the absolute value of 2 minus 8. Treat an absolute value like a set of parentheses, grouping symbols, and you get 2 minus 8 is negative 6. Then, inside this absolute value, how far is negative 6 from 0? Well, it's 6 away. And so I'm left with 5 times 6, and that gives me 30. So we have 2 for A, B was 30. C, how far is negative 13 from 0? Plus the absolute value of 0. So negative 13 is 13 away. 0 is 0 away, and I end up with a value of 13. Finally, over here, D, I have 14 minus the absolute value of negative 10 plus 3. Negative 10 plus 3 is negative 7. The absolute value of negative 7. How far is negative 7 from 0? Oh, it's 7 away. And I get 14 minus 7, which gives me a value of 7 for D. Again, office hours today at 10. This is question 1.35. So we're looking, the solution to the equation x cubed is 64. It's called the cubed root of 64. The idea is, I'm saying what times itself 3 times gives us 64. So I always like to do this. 64 is the same as saying what? What's 4 times 4 times 4? 4 times 4 is 16. 16 times 4. Oh, that's 64. So if this is 4 times 4 times 4, I know the cubed root of 64 is 4. 16. Here we have the 4th root of 16. Well, we're trying to think, is there any numbers times itself 4 times that gives us 16? Well, if I look at this, I know 2 times 2 times 2 times 2 is 16. So that happens, it takes 2 multiplied by itself 4 times. 2 times 2 times 2 times 2 to get 16. So the 4th root of 16 is 2. Here, the cubed root of negative 8. Is there anything that gets us to negative 8 if we multiply it by itself 3 times? We'll try this out. Negative 2 times negative 2 is positive 4. But then if I multiply by another negative 2, I would get negative 8. So the cubed root of -8 is -2. Notice we can take a negative, or we can take a cubed root of a negative. We'll talk more about that later. Finally here, the cubed root of 125. I see 5 and I think, well, 5 times 5 is 25. And if I have 5 quarters, I have $1.25. So 5 times 5 times 5 is 125. And that gives me the value of the cubed root of 125 is 5. Again, come and ask me questions if you have them. All right, here we're looking at problem 1-38. It's the trampoline problem. You can click on this homework tool for Desmos, and they can help you make this graph. So I'm going to show you how to do that quick. You go to your book and you click, you get this E tool. I like to zoom out because it's too close. Now, how do I get these points on here? Well, click this little plus button and go to table, and you get to make your own table. So I'm going to just put in those numbers that are over in our chart. X is 1, Y is 0.5, and notice this showed up right here. 2, 0.9, 3, 1.6. See those points show up. You'll get better and better at using this. 4, 2.9, 5, 5.2. And look at what we have here. We have this interesting looking kind of an arc up. How would you describe that? So how would I describe that? I would say that it starts out low and it starts making its way higher and higher. So let's go back to these questions. It says Charlie performed a series of jumps on a trampoline. Her coach measured the height of each jump. All right, so jump 1 was 0.5, then 0.9, then 1.6 feet, then 2.9, then got way up there with 5.2. So if you imagine jumping on a trampoline, it slowly gets taller and taller. All right, so we have the graph. I would say it is a graph that's going to have a curve that slopes up. If this pattern continues, it looks like the next jump would be like 10 feet or 12 feet. But that doesn't necessarily make sense to me, right? I don't know how high this person can get on the jump, but I know at jump 20, they're not going to jump 100 feet. It's not possible. So kind of thinking about what are reasonable maximums and minimums, I might say a reasonable maximum is like 8-10 feet high. The minimum would be 0, right? If they just stand there, they're not jumping. So, kind of a 0 to 10. It says, which family of functions could model this data? Well, that's a good question. An exponential starts to curve like that. A parabola kind of has half of that curve, but it doesn't have the negative half. So maybe we'll talk about it looking like kind of an exponential type function. But it definitely has its limits. All right. So let's take another look at this last problem from the week. That was 1-42. So it says, use your graph investigation questions from problem 1-32 to look at these investigation tools. So I'm going to grab that from the book, the questions from 1-32. And we were trying to find what? Maximums, minimums. Where did I put those? All right, either way, let's just take a look. So when we're looking at this, we need to find out what's my x-intercepts. And so if we look on this x-axis right here, we'd say, oh, it's hitting right here, it's hitting right here. And remember, our x-intercepts are always going to be when our y values are 0. So I have x-intercepts of -7, 0, and -1, 0. My y-intercept is where it crosses the y-axis. And if I kind of follow this right up here, it looks like it's crossing right about here. All right? And so that's when x equals 0. Well, if I need to know, I can look at here. If I put 0 in for x, I get 0 plus 0 plus 7. And yeah, so our y-intercept is the point 0, 7. Finally, my vertex is the point at the bottom or the top of the parabola. Well, this parabola